HelperBot is a platform fighting game that utilizes machine learning to create a dynamic artificial intelligence opponent. The inspiration for this project stemmed from our shared love of the platform fighter genre and our shared criticisms of the modern AI systems that are implemented within these games. These AI systems are generally static and can be easily exploitable, thus making them very monotonous and causing the player to develop poor habits when facing varying challenges. The primary goal of HelperBot was to create a new variation of an AI opponent that can read the player's in-game strengths and weaknesses. As a result, it can then adapt its own actions to counteract the player's choices. The end goal was to have HelperBot organically assist the player in improving their gameplay while naturally scaling the difficulty to an appropriate level. This relationship between the adapting AI system and the generic player creates a unique experience suitable for all skill levels. During the early stages of our project, we were mostly focused on planning and preparation. This included outlining basic mechanics, aesthetics, and goals of the game. In addition, we started mapping out the movesets of our player and researching numerous methods on how to integrate machine learning into the project. After the preparation stage, we were then focused on actual creation. We created the character model of our robot, then rigged it for animation. We then created the numerous animations for the robot character. This included running, crouching, jumping, hurt status, falling animations, 4 grounded attacks, 5 aerial attacks, and 1 special move, all of which was accomplished in Autodesk Maya. During this period, we also recorded various Foley sounds and mixed several tracks to include in our game's soundtrack, and added more content as we continued to develop incrementally. After accumulating all these assets, our next challenge was to implement them into a game. We settled on using Unity for our project and created custom scripts using C#. This included adding hurt boxes to the characters, hitboxes for their attacks, animation state management, sound effects and music, and so much more. Finally, we implemented a machine learning algorithm into the robot's AI. The enemy robot measures the player's position. From this, we created several unique interactions based on the habits of the player. One of the main examples is our enemy robot's ability to exploit an opponent who likes to abuse jumps. A majority of the animations were handled using a state machine that would trigger different actions based on the data being recorded from the player's actions. All in all, HelperBot was a really ambitious project for a 1-semester capstone. Game development is a long and tedious process. When coupled with machine learning, an already intricate concept on its own, it proved to be a huge challenge for us. During the process of making this game, we learned a lot of new and unique skills as a team. We are happy to say that we accomplished our project's goals with a limited amount of time, and we are tremendously proud of our final product. For the future, Seth will continue to work on HelperBot for his honors thesis by polishing the game engine and taking the project to another level with its implementation of machine learning.